Okay, here's a look at your first optimization problem. This one's pretty straightforward. Find two numbers whose sum is 10, for which the sum of their squares is a minimum. So this one sentence is actually giving us two different equations. The first equation is you have two numbers whose sum is 10. The second equation is those two numbers, the sum of their squares is a minimum. So notice this second equation has that word minimum there. That's what tells you that this second equation is your objective function. This is the equation that you're trying to optimize. That means that this other equation, this is your constraint function. Two numbers whose sum is 10. So we're told to find two numbers. Those two numbers are unknown. We need to create variables for those two numbers. Whatever variables you choose to use here is totally up to you. X and Y are very commonly used, so I'm just going to go with X and Y as my two variables. So we want our two numbers, X and Y, to have a sum of 10. So our constraint function would be X plus Y equals 10. The word sum means to add. The word is means equals. And then our objective function, the sum of their squares is a minimum. So the word sum means to add, and then squares means you're squaring each. So you would have x squared plus y squared. So the function I'm trying to optimize has two variables in it. That means right now it is a multivariate problem. So we can write it as a function of x and y. But in order to optimize it in BC, we have to be able to rewrite this equation as a function of a single variable. So to do that, go back over to the constraint function and solve for one of these variables. Whichever one you solve for is up to you. I'm going to solve this one for y, which means I'm going to move that x to the other side. Y is equal to 10 minus x. That 10 minus x, you now want to substitute that in for the y inside of the objective function. That means our objective function is now x squared plus 10 minus x quantity squared. So now our function is just a function of x. Since we have to take the derivative of f, it might help to simplify this problem as much as possible first. If we multiply out that parentheses, that would give us 100 minus 20x plus x squared. And then we can combine like terms, and that would give us 2x squared minus 20x plus 100. Now f of x is ready for us to take the derivative. Since f of x is a polynomial, I'm going to use the second derivative test, because that'll more than likely be the fastest way to find our solution. We start by finding f prime of x. The derivative of f would be 4x minus 20. We now need to find when f prime of x is equal to 0. We also need to find when f prime of x fails, if it fails at all. Setting f prime of x equal to 0 means that we have 4x minus 20 equals 0. Let's solve this for x. 4x is equal to 20, x is equal to 5. So there's one of our critical points. Does f prime of x fails? Well, this is an easy one to answer. If f of x is a polynomial, then f prime of x will never fail. F prime of x would only fail if you get x in the denominator, and that denominator has a solution that could make it equal to 0. So now we need to find the second derivative, and that would just be 4. We only have one critical value, that was x is equal to 5. So plug in 5 into f double prime of x. And it really doesn't matter what you plug in into your second derivative. Since there's no x's inside of that equation, that means you're just going to end up with a 4 every time. So f double prime of 5 is positive, which means that our graph of f is concave up. So therefore, by the second derivative test, x is equal to 5 is a relative minimum. Now let's look to see what the question was asking us. The question said to find two numbers whose sum is 10, for which the sum of their squares is a minimum. Right now we only have one number. We have x is equal to 5. The other number that we need is the y. And in order to do that, we can use our constraint function. We know that y is equal to 10 minus x. So just plug in your x equals 5 into 10 minus x, and that tells us that y is also equal to 5. So our two numbers in this case are x is equal to 5 and y is equal to 5.